Example 8 on unsteady flow. Here is the problem. A tank 6 meters long and 3 meters deep is 2.4 meters wide at the bottom and 5.4 meters wide at the top. In the bottom is an orifice having an area of 0.0155 square meter and a coefficient of discharge of 0.6. If the tank is full at the beginning, how long will it take to lower the liquid surface 1.8 meters? So let's have the figure to help analyze this situation. So we have a tank 2.4 meters wide on the bottom and 5 meters wide at the top, and it is 3 meters high, 3 meters deep, and perpendicular to the screen it is 6 meters long. It contains an orifice on the bottom having an area of 0.0155 and coefficient of discharge 0.6. Then it is full at the beginning, 3 meters deep. How long will it take to lower the liquid surface by 1.8? So if the surface is lowered 1.8, so meaning to say the final head would be 3 minus 1.8, 1.2. And the formula for this case when area S is varying is integral of area S dH over Kaotog with H. So let's draw this line to express area S in terms of the head. So this is the area S at any instant. So the length would be 2.4, then this is X, that's also X, 2.4 here. So 5.4 minus 2.4 is 3 divided by 2, so that means this is 1.5. Then area S is perpendicular to the screen 6 meters times the length of this line, which is 2.4 plus 2x. So this is the head over the orifice, and this is 1.5. 5.4 minus 2.43 divided by 2, so 1.5, because this is also 1.5. By formula, time is integral from HF to HI of area SDH over Kaotog, or C area or square root of 2GH. Then let's have similar triangles to express X in terms of H. So X as to H equals 1.5 as to 3. So X is 0.5 of H. So area S is 6 times 2.4 plus 2 times 0.5 of H, or 2X. So 6 times 2.4 plus H. Substitute into the formula with HF 1.2, HI 3. So 6 times 2.4 plus H, close the H over 0.6, area O is 0.0155, then square root of 19.62H. Computing for the constant, 6 divided by 0.6, 6 divided by quantity 0.6 times 0.0155 times square root of 19.62. Then the integral would be 2.4 over square root of h, or 2.4 h to the negative 1 half. The integral of 2.4 h to the negative 1 half is 2.4 h to the 1 half over 1 half. So it should be 4.8. 2.4 over 1 half is 4.8 h to the 1 half, or 4.8 square root of h. The second term is h over square root of h, so that's h to the 1 half. The integral is h to the 3 halves over 3 halves, or 2/3 h to the 3 halves. So time is, this is the constant, then 4.8 square root of h plus 2/3 h to the 3 halves from 1.2 to 3. Substitute limits. 145.653, 4.8 square root of 3 plus 2/3, 3 to the 3 halves minus the quantity 4.8 square root of 1.2 plus 2/3, 1.2 to the 3 halves. So using the calculator, time is 822 seconds. So if you feel it fast, then you can always pause the video, then rethink and stop and go over with the calculations.